The host company that I worked with this summer was 3P Processing, which is an aerospace parts finishing and painting facility in Wichita, Kansas. It was originally founded in 1974. And while it only initially offered wet processing and non-destructive testing processes, it has now expanded to include 3 paint rooms present in 3P's facility. It's NADCAP, which means National Aerospace and Defense Contractors Accreditation Program, accredited for 3 different types of accreditation, which are aerospace quality system, chemical processing, non-destructive testing, and surface enhancement. Just as an initial overview of the projects, the total GHG reductions that I found were around 176.2 million tons of CO2 equivalent per year, and an annual savings of close to $50,000 per year. Talking specifically about the different processes that 3P puts aerospace parts through, mainly structural parts like brackets and fuselage pieces. Setup and production is the first initial step, which includes cleaning of parts, organizing, and putting the parts into spaces where prepping parts to go through the different wet lines or paint lines. And that depends, that changes depending on the material of the part and company specifications as far as what they want to be done to that part. So the wet lines include anodization, chem film, and passivation, which are different methods of surface treatment to ensure that your part isn't going to be corroded over time. Shot peening is a surface treatment that increases the surface strength of a part. And painting obviously reduces corrosion and is important for electrical processes. Sustainability at 3P Processing is an important part of what they do as far as processes, because parts finishing is a fairly environmentally dangerous industry. Chromium-6 is a very common paint ingredient that's a cancerous chemical and is dangerous for groundwater. PCE, which is used at 3P Processing for a vapor degreasing project, which I'll talk about later, and toluene, which is another hazardous air pollutant and volatile organic chemical. Current sustainability practices practiced at 3P Processing, they use a wastewater treatment system, air scrubbers to remove chromium from the air, and hazardous waste disposal systems that are rigorous and meant to reduce the amount of hazardous waste going into the environment. As far as motivations for change, as regulations continue to adapt and TCE may be banned in the coming years, it's important to look forward rather than in the past as far as what you want to change about your plant. Along with that, reducing pollution and permitting requirements is an added benefit, as well as the economic benefits that come with P2 projects. So the first project that I looked into was about vapor degreasing, which is, so each part that goes through 3P Processing is required to be cleaned to a certain specification, depending on what the original manufacturer is for that part. So that's different depending on whether it's from Boeing, Cessna, or any of the hundreds of original manufacturers that are providing parts to be finished at 3P. So that's one of the main roadblocks as far as switching vapor degreasing, because TCE and vapor degreasing as it is fairly standard, and it's fairly standard as far as aerospace manufacturing goes. So switching to an aqueous degreaser, which is what I recommend, is a fairly difficult process. The cleaner that I am recommending is one that's specified in several of the original manufacturer. So original manufacturer being Boeing, which provides around 40% of 3P's parts. This cleaner is accepted in several of these major manufacturers as being safe and okay for parts. It costs around $15 to $16 per gallon for a 55-gallon drum. It's diluted to 15% dilution, which means that about $2.38 per gallon are spent on the actual solution used to clean a part, which when compared to the $68 per gallon for TCE is around 3.5% of that initial cost. The first actual system that I looked into was an ultrasonic cleaner tank, which unfortunately is not recommended as a standalone, as there are several other rinsing requirements specified in the company in most specifications. So since it's only a tub, it can't rinse on its own. It's not a standalone system that can replace a vapor degreaser, essentially. Well, while that's true, it could also be implemented into a tank system if they decide to make degreasing a tank line in its own right, essentially. So that would be about 5.1 month payback period for about $6,000 in annual savings. The second and primary degreaser method that I looked into was a GenFab aqueous degreaser, GenFab being the company that produces it. This is the closest as far as size and effectiveness to 3P's current vapor degreaser. So it's a standalone system that takes up roughly the same amount of space. So there wouldn't be extra needs to shift around floor space requirements. It's a standalone degreaser, and it has an internal diameter of about 72 inches and a 70-inch height, which, although it won't contain every single part that needs to be cleaned at 3P, as there's a wide variety of different parts that need to be cleaned, it should be able to fit the vast majority of parts that come to the facility. As far as the recommendation, I found that it could reduce PCE solvent use by about 15,648 pounds per year, has a payback period of 4.3 years, and reduces electricity consumption by almost 90,000 kilowatts per year, with an annual savings of almost more than $31,000. Although that's true, I do put a tentative recommendation on the GenFab degreaser as a result of it's a spray degreaser, which isn't noted in every single specification as being a reliable degreasing method, essentially. So while it would be effective, it might further research is required to see if this is actually a viable method for 3P. The second project I looked into was about paint gun cleaning, and specifically solvent reduction in that space. Currently, there are 56 paint guns that get cleaned that can get cleaned several times a day between paint types and at the end of the given painter's shift. Currently, all the paint guns are cleaned manually using brushes, rags, and solvent. Water can also be used for this. However, since the project is mainly about solvent use, that's most of what I'll focus on. Different options for reducing solvent use in this area is enclosed paint gun washers, which, although 3P has tried enclosed paint gun washers in the past, there are new different types of models that include manual aspects, which is what we'll explore in just a second, that may negate the negative aspects of an enclosed paint gun washer, being that it isn't as effective as somebody literally going in and cleaning out a paint gun. So those can reduce solvent use and increase efficiency by up to 50%. Solvent recycling, which we'll also look into, can recover 92% of influent solvent spending as far as according to the EPA greenhouse gas calculator, which we saw in Remy's presentation. The third option that I looked into was paint line agitation, which can be used to more efficiently clean out paint lines when you're doing that. Although for the paint line agitation project, I didn't look too hard into it because paint lines and pressure pot is not a type of painting that 3P uses particularly often, only when product throughput is relatively high compared to what it is now. As far as machine washing and solvent recycling, I found that there was an annual savings of about $13,957 per year with a payback period of 2.72 years. It can reach, 2.72 years. The third project that I looked into was about water use reduction, specifically in the 3P's wet lines. So that's the anodization tanks, passivation tanks, hard anodizing tanks. So this specific product is a Dynatech Chem tank cover, which would prevent evaporation from these tanks and the energy and water loss costs that would come from such evaporation. The second option, the KCH bifold tank covers, are a more high-tech equivalent because the Dynatech tank covers are essentially just a tarp that you roll over, and it has a rolling system where you use a drill to open, close, essentially. The bifold covers are more automatic. However, they are more expensive, and the company that produces them has not been forthcoming about information on the product, so I was not able to obtain the quote on that front. Dynatech tank covers are not viable for the entirety of the wet lines. It wouldn't make sense to cover all of them. It would be costly, ineffective, and it makes more sense to cover the hottest lines that evaporate the most water, essentially. Among those lines is the L215 dichromate seal in line 2, which is an anodization line. This operates at about 200 to 204 degrees Fahrenheit, so it's constantly evaporating water. And unlike some other facilities, 3P does not cool its tanks overnight because heating them up again in the morning would take an exorbitant amount of energy, given the amount of water that we need to heat it. So it's constantly evaporating. And from those evaporation numbers, I was able to find that covering tank L215 would produce a net annual savings of $49,015 with a payback period of about 1.155 years. And GHG reductions of 83.121 million tons of CO2 equivalent per year, and 96,759 gallons of water that will be saved from the tank cover. The fourth that I looked into, and probably the least meaningful, is about hazardous waste prevention in the paint rooms and masking processes. So masking prevents paint from getting on specific parts, specific pieces of a part. That tape has to be thrown away, and it has to be thrown away as hazardous waste because it's been contaminated with chromium paint, essentially. There isn't any straightforward way to reduce that type of waste. I thought perhaps reducing mass by using a lighter weight masking tape would be effective, or cleaning or laundering masking plugs, which keep paint from going into internal holes within a part, and rags used for the detailing process at the end of painting. However, I was only able to find a cost savings of about $218 per year, and that's not even considering the fact that a tape change would also be affected by original manufacturer specifications for that part. So each company, Boeing, Cessna, is going to have a different specification about what tape can be used on that part. So that's another aspect that goes into that. This is my final summary. I was able to find, it basically outlines all the things I've already said, with a total cost savings of about $49,010 with those specific environmental process values. I believe, and that's, so are there any questions?
Thank you. Questions from the audience? I do have a question. So you mentioned that the new aqueous degreaser, so the machine you recommended, the equipment would not fit all different parts that they process necessarily. So so what would happen with the ones that don't fit in there?
So currently at 3P, there are two vapor degreasers. One is in the setup area and one is closer to the wet lines. My recommendation is to replace vapor degreaser 1, which is the one that's most commonly used. The other one is used as a backup. But in this event that this is used, that second vapor degreaser could also be used as backup. And I included that. I only included half of the overall TCE consumption rate in this, assuming that the other vapor degreaser is going to be taking on half of those vapor degreasing requirements.
Gotcha. And do you know if they already have a plan for that TCE from the vapor degreaser for another, if it gets banned officially, what chemical can be used instead?
I've seen a couple of like supposedly environmentally friendly vapor degreasing replacements like that. Although I'm not sure how long it would be before those are also looked at under a critical eye.
Yeah.
And just how effective they are at what they do, you know?
Okay, so it could be another project for an intern.
And also the TCE ban is in a very early stages. It's like a proposal of a proposal.
Okay, gotcha. Okay. Any other questions? The audience.
Like in terms of the paint, is it like the paint content chromium? Is it again based on the company requirement?
Yeah, actually, airlines are pretty specific about chromium paint, and I think Emily's going to go into this further later. But so chromium 6 is incredibly effective at what it does as far as preventing corrosion on aerospace parts. And because that's such an important aspect of aerospace, it's been very difficult to phase that out of aerospace manufacturing, if that makes sense. I believe some European countries have done it, but most of the manufacturers for those parts have moved to the United States because there isn't a ban on chromium 6. Or not most, don't take my word for that.